Hi, my name is Albert M, and I'm part of the Reader Lab. My project is on wearable microfluidic colorimetric sweat sensors for real-time personalized hydration monitoring. Sweat is a valuable body fluid that is not fully understood. Sweat rate and composition are highly variant between individuals. This opens up the question on how to develop a system for personalized hydration feedback. Sweat loss is critical in hydration and also contains biochemicals that are indicative of physical exertion and injury risk. Sweat analysis can also be clinically used as diseases such as cystic fibrosis can be identified by elevated electrolyte levels. Biochemical variance is significantly attributed to sweat rate, presenting the challenge of recording a continuous sweat rate to normalize these concentrations, which would give them practical use. Microfluidic devices made with silicone elastomers collect and store sweat non-invasively and directly on the skin. This device accomplishes this as sweat is forced through inlet holes to the channels where it is stored. These channels are sealed by two bound silicone layers with an outlet hole that allows for proper flow but are engineered so that backflow and contamination are prevented. Colorimetric reagents that dissolve dependent on flow rate are placed between the inlet hole and the channels so when fluid passes by, the color will develop based on the flow rate. Studying this color development will create the colorimetric system that will visually analyze collected color gradients to identify unknown sweat rates. To test that the dye is dissolving dependent on flow rate, an experimental setup uses pressure to drive artificial sweat into the device at set flow rates. A camera records an image that is processed in Adobe Photoshop where white balance is corrected and CIE-LAB values are recorded. Statistical tests analyze for significant differences in CIE-LAB values for different flow rates at each serpentine or outer turn. So far, physiological relevant rates of 1 microliter per minute and 0.5 microliters per minute have been tested. Independent t-tests found that in the 5th to 10th filled serpentine, or serpentine from the end, contained significant difference in CIE-LAB values on different flow rates. After the 10th serpentine, the color developed was practically white, meaning there was no more dye being dissolved. Choosing a dye that dissolves at a slower rate would fix this complication. No significant difference in the first 4 serpentines may have been caused by the large variance as this experiment had only 2 samples per flow rate. That leads to the goals of future experiments where variance can be further decreased by standardizing the image recording protocol. Recording in RAW opposed to JPEG will also help as it is minimally processed and will capture colors better. Finding significant difference in all the serpentines with color will allow us to study the correlation of specific CIE-LAB values to a specific flow rate. I'd like to thank and acknowledge Jonathan Reeder, Vince Doms, and the rest of the Reader Research Group in assisting my project.